Hello, and we are Team TAZ Developers. This is our project on our specialized 2D game engine project. I'm Anirudh.
I'm Thomas.
I'm Mao. So the client for our project is Computer Graphic Technology Department at Purdue, and our advisor is Assistant Professor Jeffrey Castleman. And the problems for our project so far is many well-known game engines such as Unreal are 3D applications at their core, making it difficult to build 2D games with them. And Purdue University's game development program is more focused on graphics and modeling rather than actual programming and software development.
This is our literature review. We had a look at a lot of different resources to gain a strong understanding of things we would need to know in order to complete the project successfully. We had a look at dependency injection pattern, CPU cache optimization, script virtualization sandboxing, retro pixel art design considerations, and we also used this website called Pixel Art to gain a lot of inspiration for our pixel art designs. And in addition to that, some of our art style does have inspiration from Final Fantasy VI SNES, which is a video game.
We started by identifying the root causes of the issues exhibited when developing 2D games on 3D engines. The first issue we found was that art and objects don't line up on the screen pixel perfect. This is due to the use of floating point coordinates in 3D engines, and objects can exist between pixels, giving them a fuzzy appearance as the graphics card can't determine which pixels to draw and instead blends between them. And while this can be fixed for static objects by ensuring they're placed on integer coordinates, it is quite a time-consuming and error-prone task. Additionally, any physics, movement, and interaction code will need special adjustments to ensure that these sprites remain pixel perfect. New movement mechanics or code have to be carefully coded to preserve this behavior. Another issue we identified was resource and power consumption. We've all seen seemingly simple games that eat up battery life or slow a device down to a crawl. With laptops and mobile gaming becoming ever more popular, it is important to factor resource consumption into a game's design, so players can enjoy longer sessions and still have charge left for other tasks. The next issue we decided to tackle was that common settings and features are not configurable in-game. Features that are common to all game engines, such as button remapping, seamless controller support, and toggle keys, are only configurable in the editor. These settings need to be implemented manually along with their user interfaces, frequently leading to smaller studios or indie developers omitting them entirely. That hinders those who prefer a more console-like experience with a gamepad and can even make a game with numpad movement near unplayable on a laptop.
So for the process we used to arrive at our solution, we focused on identifying the root causes of the problems mentioned previously, and we prioritized solutions that would address these underlying issues in their entirety instead of just hiding them. And as an example, to address the fuzzy graphics and misalignment issue, we decided to use integer and fixed point math throughout the application, removing even the possibility of a sprite ever becoming stuck between two pixels. This is our project timeline. As you can see, we worked on different features of the game engine, the demo game, and the project documentation for all 14 weeks that we worked on the project.
So we used the Visual Studio for creating the game engine libraries and the performance profiling. The programming language we used is C, HTML, and the CSS. And we also used Paint.net and the pixelart.com, also the Photoshop for creating our sprites. And this code for our communication with each other, and the Google Docs for sharing project updates with our team.
Our final project deliverables is simply a zip file containing all the files pertaining to the game engine, the documentation, the demo game, and the sprites.
Some of the problems we faced was designing intuitive APIs that don't hinder the user in the long term. For our UI creation library, we chose the immediate mode paradigm, where calling functions such as button make the respective widgets appear on screen and are automatically positioned. The next issue we faced was building libraries that are easily integrated into existing projects or game engines. This is why we use the C programming language, since it's universally supported on all platforms and can be easily interfaced with from nearly any other language. Finally, maintaining efficiency in large code bases can be difficult, but with regular performance profiling after every major feature addition, we were able to identify slow code and spend our time optimizing the areas that mattered. The success of a game engine is quite difficult to measure or put into a single number. Instead, we measured the efficacy of our application against each of the individual problems we identified. To check for alignment and blur, we compared screenshots of stationary and moving objects in our game versus other engines. Resource consumption, on the other hand, was a little easier to gauge, as highly accurate performance profiling tools exist for applications and games. Furthermore, we could compare battery charge levels after running various software for a set amount of time. Lastly, for input, we compared how many different controllers and input methods work with our software versus other engines. Looking at the future, we would like to host a study where teams develop similar games in different engines so we could compare the production difficulty.
So our solution benefited the computer graphics technology department at Purdue University in a huge way. Game development students at Purdue and even game development enthusiasts have a new resource to create games. Game development professors at Purdue can now update their course curriculum to be more technical given the nature of how our game engine works. Purdue University now has access and the rights to a unique software used for developing games, one that cannot be found at any other university at this time. And this gives prospective students an extra incentive to choose Purdue University over other schools.
And our solution also benefited us on common aspects. As game enthusiasts and creative-minded individuals, we now have a new way of creating video games. Through the process of creating the specialized 2D game engine for the computer graphics technology department at Purdue University, we have become better programmers, designers, and digital artists. These are skills that can help us succeed in projects for future clients or at a corporate company. By working with each other and our project advisor, Professor Jeffrey Kesselman, we also have become better oral and written communicators.
So in this project, I gained a lot of experience in managing large code bases with many interconnected components and working with hardware such as GPUs and game controllers.
And in this project, I learned how to draw pixel art sprites for the game engine and integrate it into the game engine pipeline.
For this project, I improved my front-end web development skills, especially when developing the website for our team and while also working on the documentation. I also learned how to use Paint.net to create pixel art sprites, which was something huge for me as I had never tackled something like this before. Thank you so much for watching our presentation. If you want to learn more about it, you can email us at info@tazdevelopers.com. We can also be found on Facebook at official TAZ Developers, on Twitter at TAZ Developers, on Instagram at TAZ Devs, and on YouTube, and our YouTube channel is TAZ Developers. And our website is tazdevelopers.com. Thank you so much.